Hello everybody. I had a couple of questions just to go through some transposing, so we'll have a look at a couple of these formulas. What I'm going to do, for this they're the same formula, we're just going to learn how to move the variables around. For this, we're going to look at if I want to solve for a variable that is on the bottom of any equation that appears like this. If it's a value over a value equals another property, then how we deal with any number on the bottom is treated the exact same. So if I want to solve for b, right now AD divided by BC, so A times D divided by B times C is equal to F. Those are just arbitrary values that we pick just to look at how to manipulate this formula. If I want to solve for B, anything that's built like this, all I have to do is exchange anything on the bottom with the variable that we're solving for. And we can actually look at how that takes place. So right now AD is being divided by B times C. So it's being divided. So if we do the opposite, if we multiply this side by B, we can do the same here. And now these cancel out, and we would end up with AD over C is equal to F times B. Well, now F is being multiplied by B, so the next step would be to divide this by F. So I would have to divide this by F, which will just end up being AD over F. So this F ends up on the bottom. C is equal to B. So if we look back, all we've done essentially, this is kind of the step-by-step, but all we've done is exchange B and F. If I wanted to solve for C, I could just put B on the bottom, and C would end up being my value that I'm looking for. So that's kind of the trade-off. Any number on the bottom can be traded directly with the value we're solving for. This works for anything, even the velocity formula. V is equal to distance over time. If I wanted to solve for time, the formula would now just be t is equal to distance over velocity. Those just trade. If I wanted to solve for Ohm's law, I is equal to E over Z. If I want to solve for the impedance, they just straight up trade places, and I would be Z is equal to E over I. So the one that's a little bit more fun, so that's if we have a value that we're trying to solve for that's on the bottom. If it's on the top, it's a little bit more of a process. And for me, I have a way that I like to go through this. This is just a way. I'm sure there's half a dozen different ways that we can solve this. But for me, if there's a number on the top, we can't just straight up trade it any longer. We have to be able to isolate that. So for me, if anytime I see a formula like this and I need to solve for a value on top, I will make this formula linear as soon as I can. Right now I can do this in one step. It might take 1 or 2 steps, but make this a linear formula, meaning everything is being multiplied together. That way it'll be much easier. So if we wanted to solve for D, right now A times D divided by B times C equals F. In order to make this formula linear, because AD is being divided by B times C, I'm going to multiply this side by B times C. What I do to one side, I have to do to the other, so time B times C. And what you end up with is this linear formula. A times D is equal to F times B times C. Now that it's linear like this, all being multiplied together, I can move any variable because it's just the same function over and over again, A times D. So if I want to solve for D, I'm trying to isolate D, I'm trying to move A times D. So the opposite would be to divide by A, and I would end up with D is equal to F times B times C all over A. So that's just one method. I find this the simplest way for me to envision this. If we have this division, make this a linear multiplication formula as soon as you can. So by moving this and making it linear, it's just one step from there to isolate any value. If we wanted to solve for A, it would have just been divide this by D, divide this by D. So I hope this has helped. and I look forward to